The National Electrical Code, or NEC, does not mandate derating a circuit breaker to 80% of its rated amperage simply because it is installed within an enclosure such as a lighting panel. A common misunderstanding is the 80% rule, which applies to continuous loads. Continuous loads are defined as loads where the maximum current is expected to continue for 3 hours or more. If a circuit breaker feeds a continuous load, the overcurrent protection device and its assembly, including the panel board, must be rated for 125% of the continuous load. This is because the inverse of 80%, or 0.80, is 1.25. This means if a circuit breaker is rated at 20 amps, and it feeds a continuous load, the load should not exceed 16 amps, which is 80% of 20 amps. Likewise, to determine the minimum breaker size for a continuous load, take the continuous load and multiply it by 1.25. For example, if a continuous load is 10 amps, multiply by 1.25 to get 12.5 amps. This means you would need at least a 15 amp breaker. This ensures the breaker is not loaded beyond 80% of its rating. However, this rule does not automatically apply to all breakers within enclosures. The need for derating typically arises from specific conditions such as high ambient temperatures or multiple conductors bundled together in a raceway or cable. In these situations, the ampacity of the conductors may need to be derated to prevent overheating, and consequently, the breaker size may need to be adjusted to protect the conductors at their derated ampacity. When conductors are installed in environments with high ambient temperatures, their ability to dissipate heat is reduced. This can lead to the conductor overheating, which can damage the insulation and potentially cause a fire. To compensate for this, the NEC provides correction factors in tables such as NEC Table 310.15. The 1, which are used to reduce the allowable ampacity of the conductor. For example, if a conductor with an initial ampacity of 30 amps is installed in an area with an ambient temperature of 50 degrees Celsius, and the correction factor from the table is 0.82, the adjusted ampacity would be 30 amps multiplied by 0.82, resulting in 24.6 amps. In this case, you would need to choose a breaker that is 20 amps or less to protect the conductor. Similarly, when multiple current carrying conductors are bundled together in a raceway, cable, or directly buried in the earth, the heat generated by each conductor can affect the others. This mutual heating effect reduces the overall ampacity of the conductors. The NEC addresses this by requiring ampacity adjustment factors, as found in tables like NEC Table 310.15. These adjustment factors reduce the allowable ampacity based on the number of current carrying conductors in the raceway or cable. For instance, if there are 7 current carrying conductors in a raceway, the adjustment factor might be 0.70. If a conductor initially has an ampacity of 40 amps, the adjusted ampacity would be 40 amps multiplied by 0.70, which equals 28 amps. Therefore, the breaker protecting the conductor would need to be 25 amps or less. In summary, while the NEC does not have a blanket requirement to derate breakers in enclosures to 80%, several factors may necessitate a reduction in the breaker size. These factors include firstly, continuous loads, where the breaker and its assembly must be rated for 125% of the continuous load. Secondly, high ambient temperatures, which require the use of temperature correction factors to reduce conductor ampacity. Thirdly, multiple conductors in a raceway, which necessitate the use of ampacity adjustment factors based on the number of current carrying conductors. And fourthly, equipment limitations, where manufacturers' instructions or equipment listings may require specific overcurrent protection. When designing and installing electrical systems, it is crucial to consider these factors and consult the relevant NEC tables and articles to ensure the system is safe and compliant. Understanding these requirements and applying them correctly is essential for electrical safety and code compliance. Always refer to the most recent edition of the NEC and consult with a qualified electrical professional for specific applications and interpretations.